Alright, today we're going to land an aircraft on an aircraft carrier. So we've got a jet flying in the ocean. We're going to go from one aircraft carrier to the next aircraft carrier. This is how we're going to do it. Alright, we have to have first a position where that aircraft carrier is. So that position is at 1,750 kilometers from our position. Now we have to have a direction, and that's at 37 degrees. That would be north of east. I don't necessarily have to write that. Now, unfortunately, our aircraft carrier is moving. And that's what they do. So this aircraft carrier is moving, and the direction it's moving is, I'll write that there, moving at 63 kilometers per hour. All right, that's our aircraft carrier. Now our plane, our jet, we are flying, we're taking off from the aircraft carrier, which is going to be our origin, and we're going to fly and meet that aircraft carrier. We are going to actually solve what we're going to be flying there. But the problem is we're in the air, but we're going to be affected by windage. Okay, the wind will be blowing, the wind is blowing at 48 kilometers per hour. So I'm going to tell you how to get from our point here to that aircraft carrier. Alright, I'm back. One piece of information I did not give you is I did not give you the direction of the wind. That is a very important thing. If I didn't give you that, we have one dead pilot out in the ocean. Okay, so the wind is coming in from the south. Okay, so if it's a southerly wind, that means it's going to push it in the north direction. So ultimately what we're going to have to do is we're going to have to undershoot our target because that wind's going to push us in the north direction. Alright, things I have to look at. How do my units match up? Alright, I have an aircraft carrier that is at a certain position, but it's moving at a velocity. Okay, so what I have here is I have kilometers per hour. Ultimately what we want to do is we want to find out how or where I need to land in 2 hours. So where's that aircraft carrier going to be in 2 hours? So I have to have a time here. So time equals 2 hours. Now I don't need to convert this particular one because what we have is we have units of hour and units of hour. So I need to figure out where the position of my aircraft carrier is going to be 2 hours from now. So what I'm going to do is I multiply my kilometers per hour times my 2 hours. That gives my aircraft carrier a position of out here, an additional 126 kilometers. So I have an aircraft carrier position. Now my plane is going to be traveling at X position, but he's going to be pushed from the south. So he's going to be pushed northerly. So in 2 hours he will be pushed 96 kilometers. So it's the 2 times the 48, 96 kilometers. So I need to undershoot my target by 96 kilometers. Okay? So ultimately I am looking at a resultant down here. And that's what I'm going to be solving for. Alright, so how do I do that? Now remember, we broke down the components piece by piece. So here's what my components are going to look like. I have one component that I'm ultimately shooting for. I'm shooting for the target of the aircraft carrier. Okay, so the aircraft carrier is out 1,750 kilometers. Okay, I can solve for my X and Y components. Okay, I have a degree. My initial degree is at 37. Okay, so I have an opposite. So my opposite is my sine. So I have a Y value when I plug it in, and my Y value is going to be 1,053 kilometers. And that sounds reasonable for that. And my x is going to be my cosine value, and we're looking at 1398 kilometers. Okay, both of them are going to be reasonable figures for the type of triangle that we have there. All right, so these are my y sub 1 totals and my x sub 1. I have two other values. I have the value that my aircraft carrier is pushing out, x value-wise, and my undershoot on my plane, because I'm being pushed up by the wind, by 96 kilometers. So when I do that, I'm going to call my aircraft carrier my 2. So I have a y2 and an x2. And I'm going to call my wind y3 and x3. My aircraft carrier being pushed over because it's motoring over there is going to be 126 in the x, and the y, it's not going anywhere, so that's 0. My 3, okay, I've got to undershoot that. So my 3 is going to be a negative value on that, because what I need to do is be below it. So my y there is going to be a negative 96, because I'm below, and my x is going to be 0. Okay, so I'll do all the math on that. When I do the math, I end up with new values of y equals 957. This is my total. And my x total equals 1524. Okay, so I have brand new totals. And with those brand new totals, I have to get back to the graph board. So what I'm going to do here is I'm going to erase this. And restart. Okay. So I have a y total of 957. That's a positive number. I'm going to put it up here. And I have an x total of 1524 out there. Okay, that matched that graphical representation that we drew earlier. So now let's draw it out. Okay, I have an x value. My x value is 1524. My y value is 957. If I do Pythagorean theorem, I can solve for my resultant. Let's call that r. Just get used to that. And that's going to push me at, let's see here, 18 kilometers, or 1,800 kilometers. Now, the question doesn't ask, though, how far out do I go? It says, how fast do I need to go? So if I'm going 1,800 kilometers in 2 hours, my plane will be traveling 900 kilometers per hour. Okay, now I need a heading, I need a direction. So these are my absolutes, these are just flat out given to me. That I had to solve for, so the rounding might be an issue. But if I use my tangent here, opposite over adjacent, now remember that's an inverse tangent, or arctangent, sorry guys, of 957 over 1524, that will give me my theta value, which in this case, when I do the math on that and solve for it, it's at 32 degrees. And since we started off at 37 degrees, and we know we dropped, that 32 degrees makes lots of sense. Alright, hope you have luck with these problems, and we'll see you tomorrow.